Hi, welcome to this lesson about Golang project structure. It can be a very complicated topic, but I've tried to keep everything as simple as possible for this lesson. Be aware that if there's something something that you question, if you have a question about how to do a slight variation on what I'm describing, that I would be happy to answer questions in the comments section. And I might do another video later about some of the other things that you can do. Okay, so let's look at the two most important places or locations that Go is interested in. So here we are. The first and most important thing for Go in a way is the Go root, and that's the place where the compiler and the system libraries live. You'll be unlikely to ever want to use a different Go root than the default one. You probably never have to set the environment variable here, but a case for doing that might be if you were using a different version of Go than the one that's installed on your system, for example. So the other place that's very important to Go is called a workspace, or Go path. This is the directory structure under which all your Go projects are expected to exist. So Go isn't a sort of a free-for-all type language, a bit like C or C++, where you can organize files in any way you like. You have to put them underneath this Go path. All your projects have to go underneath this Go path when you're working on them. And so inside the Go path are a number of directories. The most important one obviously is this source directory, which is the place under which you put all your projects. So you can see here I've got two projects. One is called the super cool library and the other is called the dull project. And they both exist under source, and you can imagine that I might just have many more of them here depending on what I was working on with Go. There are two directories here which I've sort of grayed out because you're not really supposed to, you're not going to be likely to put anything in them. But when one of your modules, or like for example in this case I have this super cool library, if that library for example wanted to import a third-party module that did cryptographic hashing or something, that module will get downloaded and put into the pkg directory, and it will be built. And if that module came with any binaries, any utilities of any kind, those would be put into the bin directory under your Go path. And so that bin directory is something you might want to put into your $path variable so that you can access the utilities that get put in there. Now, there is a default Go path. It's usually on Unix systems, it's in the home directory under Go, and so for the most part you don't really have to set $Go path either. You can just use the defaults. But in my case, I'm different because I like being different, and of course the other thing about it is that I try to organize all my source code under a directory called src in my home directory. So I prefer doing that, and I prefer having my Go stuff to follow roughly the same rule, and that means that all my Go programs are going to appear under this workspace. And you can see there's a bin directory there. There's nothing in there at the moment. There's pkg, and there's some modules and things, third-party modules and things that I've downloaded. And here's src, and there are a number of directories underneath here. And so now I'm going to show you a real example. Here's a module called GitHub tnmurphy chfind. Now, isn't that interesting? What is that? Well, if you're going to create a module or a Go project that you expect to put into somewhere like GitHub or GitLab or whatever, that other people are going to want to use, then you have to lay it out in this structure with the name of the source control system and the account that they're under, and then the repository name. And what this helps you to create a module which you can then you can push it into GitHub or whatever, and somebody else can use Go to find that module and download it and build it and use it in their program. So here I have this module. So you'll see, for example, that there's a Go lessons one here. This is for all the source code for the other lessons that I've done on this in this series. But anyway, here's our little project, and it's called chfind, and it's going to be a program that does a checksum on a whole lot of files very quickly. And you might find out what that's for later. But anyway, inside this directory we have a file called main.go. Let's have a look at that. So let's go in here. So there's main.go, and you can see we've got a func main, and this means that we're going to build an executable which has the name of the directory that it's in. Let's just have a look at this file manager. Main.go is in the chfind directory, so we're going to produce a binary called chfind, right? And what this program is going to do is it's going to call this hash file function, and it's going to run it on main.go. That's because I'm lazy and I haven't made it deal with command line arguments yet. I'm just going to make it find the checksum of itself, and it's going to print out that checksum on the display. Where does this hasher.hashfile function come from? Well, it comes from this import statement that we have up here. This is going to import our own file. You see that the package name here is GitHub tnmurphy chfind. That matches our directory structure up here starting from the source directory under the workspace. This is our package name, and the bit that comes after src there is our package name, and that's what we've got in this import statement. And then we're importing a package called hasher. And if you look in our project, we have a directory here called hasher, and in hasher is this file called hasher.go, which has the code that we're looking for. So here we go. You can also see it in VS Code. Here it is, hasher.go, and in here we see that we've got a function that calculates a hash. If you look here, this is stuff you might not have seen before in the lessons. We're opening a file, we're using the defer function to ensure that the file is closed before we exit this function, no matter how we get out. It's very useful. Then we're saying if there's an error, return, and you can imagine that depending on the error, you'll definitely still call fclose, and so that no matter what happens, we're gonna close the file. And here we are copying from the file that we opened into this hash reader, which is a thing that implements a read interface. And so that's like essentially copying from one stream to another stream. And then we're going to return the checksum of the file that's been calculated by this hasher that we created up here, and nil, because in this case there's no error. Notice when we're returning an error, we were using fmt.errorf to generate an error data type. This thing returns an error data type with the string that you pass in like this, and we're returning 0 for the hash in this case. Now there's one problem, I've totally ignored it. Here we are, and here's the problem. This is all red because we can't find this module. I need to go back. There's some stuff we haven't done. Here we are on the directory. This is the directory of the project. First thing you have to do when you're creating such a directory, and that I haven't done here, is to initialize it. So I have to do this thing called go mod init. Okay. Now, if we do that, let's ls again. Now we suddenly have three files. We have this file called go.mod. If I cap that, what you'll see is that it has the module name at the top and the version of Go that we are currently using. This is what we call the full package name anyway, and you can see it's the path from the workspace /src up to the current directory. Now Go is telling us that we should do mod tidy to add module requirements and sums. That's interesting. What does sums mean, or what do they mean by module requirements? Could it be something to do with this missing, this redded out import, where we're trying to import a module and it's giving us a nasty red mark? So let's try and see what happens if we do go mod tidy. Oh, it's finding module for package GitHub 1 XX hash. That's the one that's mentioned here. Oh look, and now that has gone normal. And what has happened is that we have downloaded that module automatically and added it. Let's look again at the directory. Okay, there is yet another file here, go.sum. I wonder what that is. Let's have a quick look at go mod first though. Oops, here it had only 3 lines. Now it has 1, 2, 3, 4, 5 lines. Okay, so the new thing in here is this. And that's a require statement, which says that this module has a dependency on a module called github.com 1 XX hash v 1.2.8. Now what's happened when we ran go mod tidy, Go went and fetched from GitHub, fetched this module and built it and stuck it in the workspace in the package part, a directory under workspace, and it recorded in this module file the fact that we need this module and what version we need. So now I should be able to do a reproducible build. If I send this particular repository to you or to somebody else, you'll know exactly which version of XX hash to download. In fact, you won't even have to do it because Go will do it for you. So what's this go sum file? That could be interesting. Okay. Wow. Okay. These are checksums that help Go to know for sure that it has the correct version of a package. So the source code of the package gets checksummed, and when it's downloaded, and that checksum is stored in go.sum. And that means that not only do we know in theory what module we should be getting, but we can prove using the checksum that it really is the module that's expected. So that's very powerful. That helps you to make sure that you have a secure and reproducible build without having to keep a copy of every module that you use inside your own source code. Right. So these two files, which are go.sum and go.mod, they definitely should be stuck into your source control system. Right, now, here we are. This is now OK. So what happens if I try to build this project? I'm going to do it at the command line because I like the command line. Go build. Oh, isn't this nice? Now I have a binary called chfind, and this binary I can run, and it prints out the checksum using the XXHash algorithm of main.go. What if I change main.go? Oh, let's run it again. So I always get the same number, but now let's put in a comment in main.go. That's hasher.go. I don't want to do that. I've got to go and look at main.go. So let's put in a comment here, something along the lines of okay, program to calculate checksums. We'll let the IDE save that, and now we can run chfind again, and here we are, we get a different checksum. Hooray, it looks like it's working. Now what I can do is I can check all this stuff in, I can push it to GitHub, and suddenly other people will be able to download and use my code by using a command called go get. So I'm wondering if I should tempt fate now and try and show that off. Let's see. Let's first do a go clean. Okay, that means now I can. I've cleaned away the binary output, so now I should be able to git. I think I'm going to leave this for another time. I haven't set up the repository, so it'll cause trouble. But I can create the repository now. I can do git init, git add, git. Oh, no, I don't want to do that. I don't want to keep the VS Code stuff in there. Okay. Okay, now I would have to associate that with a project in GitHub and set it up, but at least I've got all this stuff now. Okay, what more should I say? I think that I'm just going to quickly go and have a look at the structure of the Go lessons to give you a slightly more complicated example, and because you might actually need to know it. So in Go lessons, I started this off when Go 1.17 hadn't been released, and I don't think I've run Go mod tidy, but I don't actually use anything except the standard libraries, so there are no require statements in there, and I therefore don't have a go.sum either. What is slightly different is that I have put the executable code into, I'm producing several executables. Now if you look in the chfind example, basically the main function is in main.go, and that is under the chfind directory, and so the binary get is chfind, and there's no way to have more than one binary. But in the Go lessons code I have several programs. I have the program that runs all the basic lesson examples. I have another executable which runs all the function examples, and one which is going to be for Go routines. That's an exciting thing which is coming next. And because I have multiple binaries, I cannot have them all in all the code for them in the same directory, since the name of the binary is taken from the name of the directory. So one of the conventions for dealing with this is to put the files into a directory, is to have a directory called CMD, and every directory under this is a different binary that your program, that your project is going to produce. And that's all very well. Here I have a docs directory, by the way, but that's all very well, and it's kind of neat, but it's a nuisance to build, because you have to go and build each command separately, instead of being able to just say build everything please. Or at least There may be a way, and I don't know it yet. Alright, so what have we covered? Let's just go back here. There's a Go root to show where the version of Go is, where the system libraries are and everything. You don't change that. There's a Go path. You can use the default one if you like, which is in your home directory /go, or you can create your own. And if you create your own, by the way, you have to set the variable. Oh, sorry. There we go. You see, I've set my variable. And if you have if you're using an IDE, you obviously have to go into your IDE and make sure that it has the right Go path if you've decided not to use the default workspace, if you've made your own workspace. Then under the workspace is a directory called source, and under source you put your directory structure for your project. If your project happens to be one that's going to be on something like GitHub, then so that other people can download it and use it, even automatically use it, then you have to follow a certain naming convention, and that naming convention is the domain name of the source control system, followed by your account name or whatever it is, and then the repository name. And that's it. Good luck. Okay. Bye.